In this video, we're going to illustrate how to approximate the area under a curve, in particular y equals 1 over x, from x equals 1 to x equals 5. And in this case, we're going to use 4 rectangles, and we're going to use the right endpoints in order to determine those rectangles. So the first thing we need to do is to divide this region into 4 strips of equal width. So I'll do that first. So first I'll cut it in half, and then I'll cut each half in half again. So I'll get 4 strips of roughly equal width. Use your imagination a little, and they're the same width. So each of these has the same width. Right. The next thing I want to do is label each of these widths. Now I have, counting from 1 to 5, and I have 4 equal strips, or 4 strips of equal width. Each of these, I'm just counting off the x values along the x-coordinate. I have 1, 2, 3, 4, 5. So each of these has a width of 1. You label the width of each of these strips. Now the height of each strip, we're going to actually generate a rectangle. And in order to use the right endpoint to generate the rectangle, I'm going to go with the right endpoint of each strip. And I'm going to just construct a rectangle off of the right endpoint. So I'm going along the right endpoint of each strip from where the strip meets the curve, or where the height of the strip meets the curve. So I have constructed rectangles whose right endpoints meet the curve. Now the next thing I want to do is notice that the height of each of these respective rectangles is simply the height, or the value rather, of the function evaluated at each of these right endpoints. So in other words, when x is 2, the height of this rectangle is just f of 2, because this point is actually on the curve f of x, y equals f of x, and at 2, the height is the y-coordinate, or the y value, f of 2. Here, the height of this rectangle is f of 3. The height of this rectangle here is f of 4, because at x equals 4, the height of this rectangle meets the curve y equals f of x, with f of 4. And finally, the height here is f of 5. Okay, now if I were to label each of these rectangles as having area 1, area 2, area 3, and area 4, then the total area under the curve from 1 to 5, call it A, is approximately the sum of the areas of each of these 4 rectangles. Area 1 plus area 2 plus area 3 plus area 4. Now, we can actually find the area of each of these rectangles. Area 1 is base times height, or 1 times f of 2. And then area 2, or the area of rectangle 2, is base times height, 1 times f of 3. I think you're getting the pattern here. Area of the third rectangle here is just base times height, or 1 times f of 4. And area of the fourth rectangle is 1 times f of 5. Now we have a formula for f. Remember, f of x is just 1 over x. So when we have f of 2, that's just 1 over 2. So 1 times 1 over 2 is just 1/2 plus 1/3 plus 1/4 plus 1/5. And that can be easily added using any method that you like, adding by hand or using a calculator to find your actual approximation for the area under this curve using 4 rectangles.